So just to review this problem looking for the molarity of sulfuric acid. First we wrote down the definition we were looking for, the fraction, moles sulfuric acid divided by liters of solution. Indirectly from the problem we knew the liters of sulfuric acid solution. We found that by turning 20 milliliters into liters, we moved the decimal over 3 places, and we got the denominator. To figure out how many moles of sulfuric acid, the numerator, we first had to write down the balanced chemical equation. And that involved doing a double displacement reaction, and that also involved everything that you learned before about taking the positive part, pairing it up with the negative part, making sure not to carry along subscripts like this 2, but you do carry along the subscript 4 in the sulfate because sulfate was a polyatomic ion. You also had to know the crisscross technique. You had to know the charges from the periodic table. Potassium is always a +1. Sulfate, polyatomic ion that you memorized, is a -2. So the proper formula is very important to write down because otherwise when you balance the reaction you don't get the right coefficients. If you don't have the right coefficients, this 1 to 2 ratio between the acid and the base in this case, was used as one of the conversion steps. So if it's a 1 to 1 ratio or a 1 to 2 ratio, that you get that from the balanced reaction, if you do that part incorrectly, you're going to get the wrong answer. This one is going to multiply out. You're going to get 4.43 times 10 to the -3 moles of sulfuric acid. That's not the final answer, because remember we were looking for molarity. We have the liters and we found the moles, so now we have both parts. Now we can calculate the molarity. 4.43 times 10 to the -3 moles of sulfuric acid divided by 0.200 liters of sulfuric acid solution gives you a final answer of 0.221 molar. Very, very important that you balance the reaction properly. Make sure you go back and remember how to do that crisscross technique to figure out the balanced reaction.